All right, so this is the final section of notes that we're going to go over for our chapter 3. We've got 3 things to cover today. We're going to determine the equation of the least squares, determine the equation of the least squares regression line using computer output. So what they mostly use is something called Minitab. And I should write a grant to get it installed, but then we'd have to uninstall it and reinstall it. If I had a classroom set of computers, we would do it, but we'll just show you how to read it up here. 2, we're going to describe how slope, y-intercept, standard deviation of the residuals in R-square are influenced by outliers. Specifically, what happens if x is if the explanatory variable is an outlier, like just the x coordinate is, so we're being pulled along the x-axis. And then what happens to it if it's the y that's the outlier, if the response variable is the high one, okay? And then we're going to find the slope, y-intercept of the least squares regression line from the means and standard deviation of x and y and their correlation. Basically, we know the calculator can do it, but what happens if we don't have a calculator or they ask us how to do it the long way, okay? So we're going to pull up the screen. This is where I need a laser pointer. Okay, so this is a Minitab printout that you're going to see, such as on your homework, on the test, and then even on the AP exam. The one thing that you won't see it on will be CSI unless they change it this year, their CSI final, okay? So what we've got is the predictor, constant, and miles driven. So this is going back to the question they've been talking over and over again about the Ford F-150 and the miles driven and stuff like that, and the value of the car, okay? Or the truck, excuse me. So the slope is going to be under the coefficient. So that's when it says COEF, the second number is your slope. So I'll show you what I would do when I'm with you guys, okay? So that first number that's highlighted there, that is your slope. Let me write it down real quick. And then our y-intercept is equal to 38257. And then your standard deviation for the regression line. Remember, this is for the regression line. And the standard deviation on this one is how far away are we typically away from our regression line, okay? How far away is our y? And then we have r squared, which is 66.4%. Okay, so pause that. What I'd do is I'd go to that printout, and we're going to do a couple more of those. I can't recall off the top of my head how much of this they put on the AP exam, but I'll go do some research real quick, see what we're looking at. But I would actually write down slope, y-intercept, kind of like that. Put your standard deviation and your r squared as well. And so then what happens is when it says just determine your least squares regression, you're just going to go y hat is equal to just like that. That's all you have to do. Remember, it's a y hat, meaning that it is a prediction. It's a prediction, okay? So all the stuff that's in the table or in the list, that's our, what kind of data? Observed, okay? All right, and so then if we go real quick, I make a horrible regression line, I put some dots over there, least squares. Remember, the standard deviation is what we're typically distancing from right to here, okay? We're typically that far off. That's what our standard deviation is telling us, okay? Typically, air quotes. Okay, now what we're going to do is we are going to practice. Oh boy, hang on to your hat, so hopefully this will work. I'm going to pause this real quick. All right, so this is, does seat location affect your grades? So many people believe that students learn better if they sit closer to the front of the classroom. Does sitting closer cause higher achievement to do better? Simply, choose to sit in the front. Anyway, to investigate, AP stats teacher randomly assigns students to seat locations in his classroom for a particular chapter. At the end of the chapter, he recorded the row number, row 1 is closest to the front, and test score for each student. Least squares regression was performed on the data, a scatter plot with regression line added, a residual plot, and some computer output from the regressions are shown below. All right, so this is the first picture here is a what? Negative association. Okay, good. Do we know what R is yet? So would we want to say it's a slight, or we probably want to put any adjectives with it? The only thing we want to say right now is that it is a negative association. Okay. Scanning real quick. Do we see any possible outliers? Personally, I would think that maybe either this one or this one might be affecting it, but these two might cancel each other out, so it's not that big of a deal. So, but the only way we can really be sure is if we take that one out or take that one out if we think it's bad, or take both of them out and see what happens to it. Okay? Okay, that is our residual plot, which Nathan can now do on his superior Casio. He's nodding his head. Okay, so real quick, what do you guys notice about residual plot? How about, do we, in residual plot, we can't say association. What we're looking for is there a curve to it? So is there a parabola, or is it just like all over the place? It's all over the place. So if it's all over the place, that means we can linear approximation is okay. All right. If there's a curve, one more time, if there's a curve to the dots, right? If there's a curve to the dots, that means that it's a no-go. All right. But because they're all over the place, we're okay. All right. Let's see here. So then there is our computer printout. Okay. So I want you to answer the questions and we'll go from there. I'll pause it and we'll go from there. Okay, so from the Word document, I probably upload that so you can see it online as well. But what I wrote down for my information was I put the slope at negative 1.1171. I recorded the y-intercept, I recorded the standard deviation, and I recorded the r-squared so that I could use it. Okay, so here is my linear regression, least squares regression line. So I put that X was row numbers and Y hat was the test score. Because if you remember, that's what the question was, right? All the information was given to us talking about row number and Y hat was the test score, okay? The slope, part B, this is for my benefit. It really helps me personally. If I go change of Y over the change of X, then I know that I can put test score in the Y, row location in the X. And so then I can just go along, read that just like I used to in Algebra 1. For every row a student moves back, they can expect to lose 1.1171 points on the test. Okay? That's all I really need to say. Now, R squared, the reason why I'm using R squared is that if I take the square root of R squared, what do I get? I get the R. I get the correlation coefficient. Okay? So I have to change it from a percent back to a decimal. I take the square root of it and I get 0.2167. Why did I throw a negative in front of it? Yep. Correct. So it shows us that it's a negative association. Okay. Now, with a negative 0.2167, instead of, what did you say, a slight negative? Right? So with that negative 2.2167, I'd almost say that is a weak negative association. Right? So there is some type of association, but it's pretty weak. Okay. And then part D is yes, because there's no curve in the residual plot. Okay? Questions? So obviously, an outlier is an observation that lies outside the overall pattern of other observations. Points that are outliers in the y direction and not in the x direction of a scatter plot have large residuals. So if you think about it, you've got your regressions line here. Okay, we're talking about an outlier that's up here or even down here. So that residual is going to be a lot different from that that vertical stretch is going to be right there. Okay, so and we're going to classify an outlier as something that has a large residual and it's influential on the y. Okay, the next one we're going to talk about, the influential, talks about it being on the x-axis. Okay, so that's what the outlier does. Now the other thing that we got to talk about, this I'll talk about that here in a second. I want to get both of them up here before I carry on. Where'd you go? So influential, an observation is influential for statistical calculations if removing it would make a noticeable change to the results of the calculation. Points that are outliers in the x direction of a scatter plot are often influential for the least squares regression line. So reading that out loud just kind of gives you that opportunity to think about it. What happens to both the outlier and influential variable is if we look at it and we say, I think that one is an outlier or it's influencing the least squares regression line. If I take that out and it's a noticeable change, and see, that's the thing that's kind of grayish, is what may be noticeable for me, somebody else can sit there and go, that's not too noticeable, that's fine, all right? So the way you're gonna have to do it is for us, it will be noticeable. Okay, so you'll have a line that says is, say a pretty strong positive. You take out something and it drops it down. That's going to be pretty noticeable. Okay, they're not going to try and trick you or anything like that. It will be a significant drop. Okay, so and they usually will tell us what point to take out. All right, because then there's other guys who've been doing this for years that will notice it. Okay, it's not like in our box plots where we could do the calculation and find out which one is an outlier for sure. Okay. Okay. So remember a couple things with this real quick. We are going to first remember that you need to know which ones are explanatory and which one's your response variable. Make sure you understand the two differences. All right, and explain which ones are which. Number two, your correlation and regression lines describe only linear relation. Correlation and least squares lines are not resistant. Association does not imply causation. Number four is like key. There's been a question on the AP exam every year and on the CSI final. Here's your association. And that means that this causes this. So if you can take anything from this chapter, association does not imply causation. Okay? That's the key thing to remember from that one. Example. All right, so what we've got is the equation of slope is equal to r over the standard deviation of y over the standard deviation of x. That should be times, something like that. Your y-intercept is equal to the y mean, or y bar, minus a, which is our slope, and x bar, our x mean, all right? Now, in the book, they're going to put that as b, because they're using this as their form. They're using that as their form. And remember, I'm saying use this one, so that way we're not getting confused about y-intercept, okay? All right, use this data set to find our points that we need, okay? So I need you to put column A in list 1 and column B in list 2, and then we can go from there, okay? Okay, so we got the list in, put it in. Now we've got two variables this time, correct? So here's the cool thing. We could do each list individually, but since we have two variables, we're going to go to two variable stats. Hit enter. List 1 is my x, list 2 is my y. And so we're going to hit enter.